Okay, I'm going to fly through a couple of these root locus for you, just to take care of, show you some examples without taking a lot of time. So we've got this transfer function, k over s times s squared plus s6s plus 25. So we've got three poles, two complex poles, one real at the origin, and no zeros. So we've got three poles going, or three branches going to infinity. We can look at the root locus. We're going to plot the points on here, and I've already done the math on this, and so we've got poles, a couple of complex poles in here. Where did I do that at? Yes, at minus 3 plus or minus 8j, and so we've got a couple of poles out here and out here. And so we look at what is on the real axis and use the pin up, pin down rule, and we see this. Now we can also then draw the asymptotes, and I have done the math on this also, and we find that the intersection is here at minus 2, and so we've got three poles, so we've got one asymptotic line going towards minus 180. We've got the others going at plus or minus 60 like this. And so we know that we start at the open loop poles, go to the open loop zeros or infinity. So we've got two branches here at these complex poles that are going to have to go off this way along those asymptotic lines. And so that's what's going to happen on this. The interpretation of this is going to start off oscillatory because of our complex poles we've got in there. We're going to have it slowed down by the pole at the origin. And then as we start increasing the gain, it's going to get a little faster, but it's going to get more undamped also as those complex poles move into the or move to the right half plane, and fairly quickly it's going to go unstable. So not a really good system, similar to the one we did in lab there. And this one almost identical to the previous one. We've got a couple of poles. We've got two complex poles out here, one pole at the origin. Again, we're going to have asymptotic lines in here. We're going to have then our root go this way and the root goes this way, and so very similar to that one, so I'm not even going to spend much time on that one. This one's a little more interesting. We've got four poles, two real and two complex, and so let's look at plotting those. We've got one at poles at the origin, and then we've got one of the poles at minus 1, and I've done the math on this, and the roots on this are at minus 2 plus or minus 3j, and so we can plot those in there, and that's going to be somewhere like up in here, like here and here. And so then we look at where our asymptotes cross the axis. I've done the math on that also, and it is at minus 4/5, minus 4, or I'm sorry, 5/4, minus 5/4 for that. And so we've got our asymptotes. Now, in this case, we've got four poles, no zeros, so we've got four branches going to infinity. And so this makes a cross kind of pattern, or an X, and so we've got our asymptotes going in here like this for this case. Now let's look and see what we've got on the real axis. We've got this on the real axis, and that's all we have on the real axis. And so these are going to come together and they're going to branch out. They're probably going to follow this asymptote out like this, and then these complex poles are going to follow this asymptote out like that. And so that would be the solution to this. The interpretation of this, we would have it, these poles, the real poles are going to get a first order-ish kind of response to them, and we can speed that up a little bit as we increase the gain to where they're critically damped. Now these other the complex poles are going to play a little bit of a part initially, and we're going to overlay an oscillatory, second order oscillatory system on top of our first order system, so it's going to have some oscillations on top of it. Pretty quickly, those are going to move out to where they can be considered high frequency, and the system is going to be dominated by what's going on in here. And as we move out here, we're going to go unstable. So here again, this system is not going to be stable very long as we increase the K on that. Anyway, so that's a couple of real quick ones. So you can take that and use it as examples.